a star dying, a planetary nebula called the Southern Ring. Let's do it.
Oof.
Wow, wow. This near-infrared image is, wow, the detail. Oh. Wow, okay, well, here we are. We have a near-infrared image on our left, or on maybe your right. And here on the right, we have a near-infrared image. And so I'm here with Carl, our astronomer specialist. Can you tell us what we're looking at in these images?
So this is a planetary nebula. It's caused by a dying star that has expelled a large fraction of its mass over in successive waves.
Okay, so we actually see those waves in these images.
Yes.
Wow, wow. And so there's a lot of structure. Can you tell us a little more detail about what we're looking? Maybe start with this one on the left.
Yeah. So in the NIRCam image, you see this kind of bubbly, almost foamy appearance throughout the whole nebula with some very structured shells. And this foaminess is showing up in orange mainly, and this is due to the molecular hydrogen that's newly formed in the expansion, just lighting up the gas and dust of this nebula. And then as we move inward, you see this kind of very blue haze in the inner region, and this is actually due to very hot ionized gas that emits well in the blue, that's heated by the core, the leftover very hot core of this star.
And what about these like rays that I'm seeing in this image?
Right, so there's also rays in the outer regions that you can kind of see, and these are holes in the inner nebula that are actually allowing the central star's light to come out and kind of light it up like patchy clouds with the sun shining through.
Wow, oh yeah, that's what it looks like. That's so cool. So you're actually a mid-infrared astronomer, which is different than near-infrared. And so what can you tell us about the details in this mid-infrared image?
So it looks quite different in color, partly because we're seeing different kinds of physics going on here. So we're actually seeing in the blue, you see a lot of blue. The blue is actually due to hydrocarbon grains that are emitting very strongly in the blue for MIRI. And they show the very similar structures to what we see in orange and NIRCam because the hydrocarbon, the molecular hydrocarbon actually forms on the surface of dust grains. And so again, as we move inward, we see that the inner region is again hot ionized gas, but now it glows red because that's where it emits the strongest for MIRI wavelengths.
Okay.
And then as we go into the center, we see kind of the surprise for us, which is we knew this was a binary star, but we effectively didn't really see much of the actual star that produced the nebula. But now in MIRI, this star glows red because it has dust around it. So in MIRI, we got to see both stars very clearly.
Yeah, you can't see it in the first image really, but there's two stars there. So that's a fun surprise. And I think that there's another little Easter egg you want to tell us about?
Yeah, so this was, the Easter egg is this kind of narrow filament up in the top that's radially aligned. You can kind of see it very clearly in the MIRI image. It shows up as this blue structure, and it points very much to the central sources. So I thought, oh, this must just be a density enhancement in the outer nebula. I thought that very, very strongly, but other people on the team were like, no, it's a background edge-on galaxy. Well, I made a bet that said, no, it's part of the nebula. By the way, I lost the bet because then we looked more carefully.